Hello everyone. We have just started our DevOps CTO webinar. I'm just going to give it a minute for people to join us today. To kind of get started and to introduce myself, I'm Daniel. I work in the marketing department here at CyberDuck, and I will be one of your hosts today. In terms of the agenda for today, quickly we'll be giving you the house rules. We will also be running through who is speaking today and giving you an introduction to who we are at CyberDuck. Following that, we will have the webinar itself running through what is DevOps, when you need to use it, getting the team culture right, managing the right tools, and then we'll be finishing off today with a Q&A. So just in terms of the house rules, the webinar is going to run for 1 hour. We are streaming both on Zoom and YouTube. We're going to leave some time at the end of today as well to run a few Q&As. For anyone who wants to submit any questions, if you're on Zoom, you should hopefully find a Q&A function at the bottom of your screen. There'll be a nice little button that will open up the window for you. For people on YouTube, you should have the chat box on the right of your screen, which you can use. You can also post any questions to us on Twitter after the webinar using the hashtag DevOpsDucks. And speaking today, we have Sylvain with us. Sylvain is one of the co-founders of CyberDuck, and he works on the client service officer. He comes from a very strong technical background, and he turns our client requirements into digital solutions that are secured, scalable, and compliant. He used to manage our VPS servers back in 2006 when everything was done manually, and has supported our DevOps journey to where we are today. We also have Matt with us from Fitch Learning. Matt is one of our clients we've been working with for over a year now. He will be sharing some of the pain points he's experienced and how DevOps has helped him reach a better place. We also have Indira, who is one of our senior project managers. She's going to explain DevOps for delivering better projects for clients on time and on budget. And then finally, we have Gareth, who is one of our technical directors and has been at the company for 10 years now. Gareth oversees the development, quality assurance, and DevOps teams, as well as defining our tools, processes, and training to ensure overall quality of what we deliver. Before we get into the webinar itself, I'll be passing on to our CEO, Danny, just to give you a bit more of an introduction to who we are.
Hello and a warm welcome to everyone. So we have people from all over the world today, so thank you so much for joining us. I believe we've got people from America, Europe, Africa, and Asia, so it's a truly global audience. And we're CyberDuck, we're a truly global business. So together we help clients to transform digital. We've been doing this now for over 15 years. Clients have been trusting us to transform complicated web applications, systems, into something that is extremely user-friendly and pleasurable to use. We follow an ISO certified user-centered design process to make sure that user requirements and stakeholder requirements are captured throughout the process. We also undertake data and technology auditing as part of what we do, and we're extremely strategic. I just wanted to share 2 examples of some of the work that we've done recently. One of them, besides obviously Fitch Learning, who will Matt will talk to you later. So Sport England, their job essentially is to promote public health in the UK. And we've helped them to consolidate multiple websites and applications, transforming it through user-centered design, accessibility, content strategy. In terms of our DevOps role on the project, involved setting up multiple applications on AWS, and we were utilizing automation tools such as Terraform and Buddy. The next example is the College of Policing. Which again required a consolidation, modernizing legacy systems, and technology, improving accessibility, creating an enterprise search, and conforming to WCAG 2.1 accessibility guidelines. The DevOps work here again included automated deployment to gov.uk's platform as a service, and we're also monitoring obviously both the Sport England and College of Policing continuously to make sure that the application is in its prime. We also, before this particular webinar today, we conducted a survey with the community of developers, CTOs, tech directors, and DevOps professionals. And we actually asked them, what is your biggest challenge in 2020? Is it a lack of knowledge around your tools? Is it the outdated infrastructure or isolated teams? And actually, the biggest challenge that the community came back to us with, and this was over 2,000 votes, was resistance to change. And obviously one of the things that our experts will discuss today is change and how you can implement that change in your organization. So I'm really excited to hear all of the speakers. Back to you, Dan.
Thanks, Dan. So we'll start back to basic really and look at what is DevOps. So it comes, the word comes from the development and operations, and it describes a set of tools, principles, and processes that really unify the entire software development lifecycle. It's quite a geeky term. It surrounds usually the technical team with the programmers at the heart of building the applications and the system. But the critical part is really the link and interaction with the other departments, from project managers, business analysts, and more importantly, the IT operations team, usually in charge of the technical infrastructure. And we'll see today that DevOps is really strongly embedded in agile methodologies. It follows all the best practices around rapid iteration, continual improvement, and where we can say that agile bridges the communication gap between the clients and the developers, then DevOps is kind of the next step in the chain where it's bridging the gap between developers and IT operations team. So historically, the term was first coined at a conference in Belgium in 2009. It's nothing really official, but so at the time with the rise of cloud-based technology, really enabled new systems and processes to be put in place. I don't know if anyone in the audience here remembers the time when we had to wait for 2 or 3 weeks for the hosting partner to provision a new dedicated server in a data center. I remember I've been through that several times. But in the last decade now, we can spin up new virtual machine in seconds, and obviously that opens a lot of new possibilities. We have to remember the goal of DevOps is really to reduce the time between requesting a change and then that change being deployed into production and everything that needs to happen in between. So software obviously is very important. It's running mission critical applications for a lot of companies. So we all need to ensure the highest quality possible. And sometimes that comes into the form of removing human errors and human intervention. And that's where the beauty of automation comes in. And it's also important to remember the compliance and security part of this process. So you might have heard terms like continuous integration, continuous delivery, and those keywords of the continuity of it is really highlighted in this loop that DevOps is actually never finished. When we talk about automation, there's a lot of different moving parts and a lot of work to do to improve, to optimize, to upgrade. So yeah, the quality is really important at every step of that process. And this loop is also known as the tool chain because it covers several disciplines, it involves multiple teams, and we'll explore each one of those in more details in a few minutes. But first, let's look at the real life case studies from the perspective of one of our clients. I'm going to hand over to Matt from Fitch Learning. Over to you, Matt.
Hi everyone. So essentially my role is I'm actually a DevOps and that's what I do. But when I started, I was really to look after the development team. But as your role evolves, there was this other side to it, and the marketing team. And from the outset, I was being involved in meetings, and as you do, trying to understand parts of the role. there was the current relationship is we held the AWS resources, and it was for 4 client sites. Well, it is for 4 sites. And then there was another agency, external agency, who looked after the source code. So it was kind of also there was another trying to understand that relationship there. But as time went on, there was a release they were trying to do a release, and that was 6 months overdue. And so again, there's all this alarm bells of why is that? What's going on there? And it was quite difficult because if there was a problem, I'm not there to blame people, but it's more about trying to understand of where's the issue and who's the responsibility. And it's quite difficult to know that from if we own the infrastructure to, and if you don't own the source code, and trying to understand that perspective of that. So yeah, okay. So I'm going to the next slide. And as I delved a bit deeper into this whole infrastructure, that it was all very different across. So we had different. So QA wasn't like live. The servers were different. The databases, different versions. So for example, a live would have an external database, but QA would have an internal database. But again, that would be a different version to what it was on live. And also the QA was out of sync with live, so it was probably about 6 months out of date. And so if you're doing a release, it's what level of confidence have you got? Because that's the whole point of QA is to apply it in QA and then test it, and then okay, and then when it goes to live, it should be just, well, yeah, it's going to work because we've done all the testing and everything. But there wasn't real that confidence. And to be honest, the whole marketing team were also very nervous, kept coming to us and asking us sometimes fundamental questions. And you think, well, okay, why are they asking these? So they also seemed very nervous as well about what was happening with their own product, really. So yeah, okay. And that's just kind of an overview of. I'm not going to go into the details of all those, but it's essentially that just the versions from different for all the different 4 sites. Yeah, we're just all over the place, and so that's just some of the stack that's there. And again, it's just very difficult to understand what's there really. And in today's world, the game has changed, and so we're being hit by external services all the time, and so we need to know. Well, not only to know what hit us, but we need to make sure that our security patches are up to date. But again, this is quite difficult, like Drupal updates. And so sometimes we actually miss applying them to QA. We just do hot fixes straight to live. So again, there's a lot of vulnerability, and we needed quite a lot of expertise around us to make sure, okay, we're making those changes. And that's not kind of the way it should be. It should be the whole point of it is to have a process, to have some confidence that that it's going to work as well. So yeah, so it was just all inefficient really. And also I was trying to upskill some of the marketing team, again just trying to help them with some of this workload and try to understand of the intricacies of this, because all these environments were so different really. And then I wasn't part of this. This wasn't part of my role, but the marketing team decided to look for another external agency, and the relationship was going to be different, where they were going to look after the whole infrastructure and also the source code. And this is where CyberDuck came on board. And from my perspective, it's really just helped, because now I'm not involved in the marketing team anymore. But I still answer questions, but the questions are very different. They're a lot more calmer, and it's more reassurance now. So and so in that side, I would say that's great. But the transition from ours to CyberDuck was again from my side, it was very easy. I was asked to provide various information like databases and versions, and so and by allowing that process, and so I don't have to think about it anymore. So There's also, because of our bigger company, which is the group, which is part of Fitch, they've also got a lot of security requirements. And so CyberDuck have been working closely with the group about how the environment should be set up as well. So again, I haven't been involved in that, but again, that's something that's gone very smoothly. So again, that's yeah, a very good service from our side. Thanks.
Thanks, Matt. Yeah, great. Thanks again, Matt. Like most thing in IT, again, the tech behind the scene that does not really matter. It just needs to work. But everything we do really surrounds people. The software is there to help us, to serve us, but it's real kind of developers and project managers, person like us, we can make things happen, and we all need to collaborate. So now we're going to hear from Indira, our most senior project manager at CyberDuck, to see how she integrates DevOps on their day-to-day job.
Thanks, Sylvain. Well, it's quite following up from what Matt was saying. As a project manager, my role is to make sure we deliver the projects and we deliver the product on time and on budget. All of that begins with having good communication at all levels, both with the clients and with the internal teams. The DevOps loop that we explained earlier and how that works, it's quite of a mirror. It's the same mirror of the project development, of the project cycle, of the software development cycle. And it begins with the brief. It begins with the definition of the requirements, the scoping of those requirements, planning them out, actually doing the technical work of development, then testing it, deploying it, getting it through UAT, deploying again, and then having a sign off for it. Many clients, you have to kind of fight through that process and kind of showing them the step-by-step part of it, but there is a reason behind it. There's a reason why we follow these steps in a certain way, and one by one. Where DevOps comes in is in automating these steps and making them so refined and so streamlined that you can actually, automate them out to build trust into the process and make it part of the process, ensuring a good delivery from the brief, from the testing, and it happens so in such an integrated way, involving the whole team. At the end of the day, it's not just pushing the button, but making sure everybody within the team aligns into the bigger purpose of it. So it's all about having visibility of the process, knowing where you are in the process and what play you have into it, involving the internal project team, the internal stakeholders, and the client side in the definitions, and sharing knowledge, making sure everyone is aware, not just as to their part, but as to everybody's part in what they're doing. In terms of the sprints, again, the DevOps change is very similar to the project management and software development cycle. And it can happen in one sprint, and it does happen into that one first iteration and that one environment. Sprints, by definition, are usually a 2-week-long process. But what happens with DevOps is it takes it from that first step on that new project, that first UX stages, it takes in from that information and what we want on the requirement, and makes sure we refine that and make that part of the planning. What do we want and how do we make it happen? And tries to automate all of those interactions and all of those happenings into the final process to get them through live. So you have the requirement, this is what we want for our product, you have the team build it. And while we're building it, we're working with the client and the product owners to test it, to make sure that's exactly what we want. And during that test, it's just not manually testing it, but making sure we can automate that testing into the deployment and into the process. Gareth later on will give us a few pointers and a few tools on how to best approach all of this automation and making sure that cycle doesn't just happen internally, but outside of it. So it's all in an effort to make a rapid iteration of the sprints and the fast development of the product. And that comes in from that upfront work to configure the entire process to make sure what we want gets into the planning, what we want gets into the development, what we want gets into the testing. And once all of that is set, then we create the visibility, increasing communication and increasing collaboration throughout. So we put in all of these tools. So again, everyone has visibility into that, and everybody knows the workflow and knows their responsibility within the operation. Building on top of it, we make sure the communication is clear enough and everybody, has a say and all of the priorities are taken into it. Other than that, we make sure that at the end of the process, we're not just celebrating that things didn't go wrong, that it didn't break on that final deployment. As Rebecca Parson said, the deployment at the end should be about the value of the new feature and how fast we got it there and how fast we keep getting it at every time, and not just, a relief that nothing went wrong into the process. But Gareth and Sylvain will tell you all about the different tools and methods that can help us get there through DevOps.
Cool, thanks Indira, very nice. So let's look now a bit more detail about the various tools and how we apply them. So if you Google like DevOps on Google Images, it can be quite intimidating. There's obviously a lot of tools, some specific for one tech or one hosting providers, some that try to encapsulate several steps of the process. They will have different configuration or file format. So there's a lot of information that needs to flow obviously between the stages. Like we've seen with the team members and communication, we want to avoid silos of information here. So it's really about picking up the right tools and make sure the tools can talk to each other. But before you can do that, you also need to understand how things work. You need to have done it manually before to be able to automate it. So you can really troubleshoot if something was wrong, or also configuring it in the right way. So it's useful to have the experience of having built servers manually 10 years ago and gone through the pain of repeating that for every new website that we launched. And now we can enjoy the benefits of automation. So before picking tools, really it's about looking at your team, the skills that you have in-house, and pick what your team is comfortable with and what's the most compatible with your stack. Or hire an agency like us who can take care of the config, and then as a CTO, you can just enjoy the results, nice dashboard, and present the good stats to on your board reports. So looking at the loop, the first step is the planning. So in terms of application planning, we're not going to do a course on Scrum and give you too much details, but as most of you know, it's very important to identify the requirement of the application, break down large module into smaller components, the user store, building user stories, and focusing at this stage on the end user value. Because as I said, that's where you're building software, that's who you're building software for. But once you highlight that, once you've defined the UX process and starting to think about how you're going to build the thing, that's when you also need to involve the quality assurance team to write down all the acceptance criterias, work with the marketing team around volume and scaling, and how much traffic the application needs to handle. And it can be quite time consuming, so that you need to make sure you plan enough time well before sprint starts to clarify all of those things. So when it comes to building it, developers know exactly what they need to build. And then on the infrastructure side, we also need to plan the server, and we can use tools like Cloudcraft or Draw.io to help you map all the infrastructure, how the database will communicate with the servers, the security of VPN, firewalls, and all the other services that you might need, like cache and search. And by planning that early on, you can validate it with your InfoSec or IT compliance team. We can review the recovery time objective, the backup process, the redundancy that you need, and then you work with the business to find the right balance between the costs and the level of redundancy that you want, because you can add more servers, you can have multiple availabilities on multiple regions. A lot of that will increase costs. So it's about finding what's right for your business, for your application, and level of risk that your company is ready to accept. So as a summary of all the tools, there are hundreds of tools to plan requirements and manage sprint and software development. So the most popular, we use tools like Jira that integrates well with a lot of other systems, ClickUp, Notion's documentation, or some tools that are more specific for your stack. As I mentioned, if all your servers are on Microsoft Azure, then the Azure DevOps will integrate very well and interlink everything. And on the infrastructure side, we've seen Cloudcraft and Draw.io to draw those pretty diagrams. Next on the loop is the source code. So it's very important to manage that. And obviously the best practices as a team is having a Git repository, allowing multiple developers to work in the same application. And again, here you can configure repository templates with all the right default settings, the right folder structures, the README files, some of your queue parameters that can be templated again if you always deploy to the same architecture. So there's some automation you can do when setting things up here. And then as part of the working collaborative process from your development team, we recommend following the GitFlow process or a version of GitFlow that you can adapt for your team. It basically defines a strict branching model, and it's designed for projects that have scheduled release cycles. So basically it starts with the production being the master branch, but when you start building a new feature in a sprint, you create a separate branch, a unique branch for your isolated feature. Multiple developers can work on multiple features, and then they all come and merge through pull requests. And after code reviews, merge to the develop branch, and then multiple of those features can then be bundled into one release to then be going through testing, staging, and production server. And there's also a process for a hotfix. So if there is an emergency that needs to be bypass the longest release cycle, then you can use the hotfix to deploy something quicker. And then for the development stack, in terms of the environment, there's always a big risk around something that runs in the local developer's machine that might not run on the production server. So as Matt was explaining earlier, the compatibility of all so many different products and services can become very tricky. So to work around that, we use container services such as Docker or Vagrant, and it gives basically the same configuration, whether you're locally or on the cloud servers. We can map exactly the same version of each software. And again, it reduces the risk and it helps for new staff as well of joining to the project. They can just spin up, they don't need to reconfigure their machine and spin up the same development environment and join the team. So similar summary here. If you are on a specific stack, there are dedicated like repositories, just Azure repo or AWS code commit, but more generic Bitbucket and GitHub obviously are the leading platform. GitLab, there are some others. Obviously, we can't show everything, but those are the main one we configure for most clients. And for local environments, Docker, Vagrant, or Rocket, new player on the scene. But pick the generic one if you need, or some framework-specific one like Laravel Valley or some others that might be relevant for your section. So I will hand over to Gareth, who will take us through the next few exciting phases of the DevOps loop.
Thank you, Sylvain. So you've built all your code. And now you need to sort of compile it together to get it onto your server. Back in the day, a lot of people are still doing this. Developers would be building their applications directly on their development machines. Obviously, that then brings in some risk of something going wrong, an environment being different. So a lot of the time now, people are using automated pipelines to keep consistency within your releases and building your applications. Building your application really depends on your stack, but standard things that you would be doing is installing dependencies, That could be node packages, that could be composer package, depending on your stack. Very common to be compressing images, building JavaScript components, minifying CSS here, and then basically pushing that on to however you're going to deploy it. In terms of build tools, there are a whole sea of different build tools and pipeline tools out there. Azure and AWS now have some pretty mature pipeline tools if you're deploying to those particular clouds. But if you're deploying to multiple clouds, or maybe your own VPSs or something else, Jenkins is a good solution if you want to just host everything yourself and configure everything yourself. But Buddy is one that we use, pretty good product, and also Bitbucket and now GitHub also can do these builds directly on their platforms. So once you've built your application, a very important step in the DevOps pipeline or DevOps process is testing your application. One of the main things you can do here is continuous integration. So what continuous integration is the process of building, which is the previous step, and also then testing your whole application to make sure that it's still working and all the new features are integrated properly. There's tools that all the pipeline tools that I mentioned in the previous step can trigger these tests automatically and then give direct feedback back to your team whether there's any problems in the build, and it goes through the regression. There's a number of different types of tests that you can build in your application, all the way from small units of code and actually going into the code, all the way through to testing full features within your application for integration. As your application gets more complex, it's really important to go back and do the regression, test all the previous features to make sure that you haven't interrupted anything that was there before, maybe years before. And you don't want to be manually testing everything because that gets very expensive. What the ultimate goal of this is to really free up your team, free up your developers to be spending more time building new features rather than going back and hunting down bugs, debugging things. Then you can celebrate having new features rather than just, again, like as Indira said, just celebrating something going right for once. Another sort of thing you can automate is browser testing. It's still quite common for people just to have QA teams just manually testing through sites, but there are methods that you can use through automated browser testing to test actually what the user sees. On web projects, like what we build most of the time, it's really important to test across browsers and across devices to make sure it all looks great. QA engineers have a variety of tools that are mainly based on Selenium WebDriver, and that means you can run all your regression as the user sees it in parallel using these tools. In the screenshot there is showing off a screenshot comparison tool. Basically, you can test your whole page, and then when you make a release, it can go through your whole site and see if there's any changes, and it actually tests the tolerance between two releases, and it can alert your team if there's something that looks really odd. With Ghost Inspector as well, that we use quite commonly, there's a video playback tool that gives your developer, you don't have to replay it and reproduce it yourself. The video can then give you a bit of a foot up in terms of getting to that problem on the site as quickly as possible. In terms of test tools, a few that we've used, as I said, Selenium kind of backs both of them, but you can use Selenium Raw if you please. Ghost Inspector, Catalan is quite popular in the industry, along with a few of the other ones. There's a bit of a shout out to SmartBear there. They've got a good suite of tools that cover a whole host of different ways of testing automated. So then you want to be deploying your application. There's two different things here. You want to be orchestrating and deploying your infrastructure, and then onto that infrastructure, you want to deploy your application. All the tools that we're talking about in the pipeline are essentially a continuous deployment process where any changes that are made and approved can be automatically pushed out to testing environments, so you're testing that code as quickly as possible. No manual uploads or tweaking things in consoles. That's the idea. In terms of deploying your infrastructure, we tend to use infrastructure as code a lot. This removes what we call a snowflake effect between all your environments or all your instances of your servers. By using infrastructure as code, then everything is audited. You can see what has changed and what software you're using on those boxes. If you need to spin up a whole new environment or in a whole new region in one of these cloud providers, you can just do that by essentially almost most of the time just rerunning your code in that region, and you've got a new application running there. A lot of the time now, these providers like Amazon and Azure and DigitalOcean even now recently, they have platform as a service services that you can deploy to, essentially removing all the operations tasks from you, and they manage updates, they'll manage scaling for you. It's really useful and worth looking at. But again, Terraform can then work with these platform as services to orchestrate, and you can still use infrastructure as code with them. Testing sandboxes are really useful as well. For running this automation, you don't want to be just leaving servers and environments just spun up in whatever cloud platform you're using up all your money. You can use the APIs that these offer to spin up environments, do the testing you need, whether it be automated or manual, and then spin down those services. In terms of release plans, next slide, please. No good, going back to the planning stage, this is kind of the deployment release plan. You want a good Git workflow, you want to be managing your release as well. You want a run book. This will probably include all the steps that your scripts will be running and who should be responsible for running these scripts, if there's any of those. Share those run books with the whole team, so everyone's aware of when things are happening. Rollback plans are really important as well. Blue-green deployments, that's a lot of the cloud platforms can implement, means that you can roll back quite quickly. But testing your rollback and making sure that you can roll back if something was to go wrong, or what you've pushed into production isn't working as expected, is really important as well. And a lot of companies now require some kind of change control. And taking advantage, that's a big sort of talk in itself, but utilizing the tools and getting the information out of the tools, it just speeds up your whole process. Some of the tools that you can use for deploying, AWS and Azure, again, they've got their own tools for this. Terraform can work with all the major cloud platforms, so it's really useful from Azure to Google to AWS and others. Buddy, again, a tool that we use really quite a lot across our platforms, can deploy as well on the end of the pipelines. And for infrastructure and managing infrastructure, we find that Ansible, Puppet, as well as Chef, that's not on the list, are very good options for managing your infrastructure as code. So you've got your application into the cloud, it's working, that's great. But you need to be basically monitoring and feeding back into the process on any issues that you see. In the basically, there's two steps to this. We find that we need to be monitoring your infrastructure first. So we want to go through, we want all the metrics of the servers. We want to see how much load there is, how many users are using the service. We want to be setting up triggers and notifications to the team in a timely manner, so they can basically jump on anything if anything's looking a bit strange. Also, we want to be feeding that information back into the process so we can optimize our code going forward and also optimize our infrastructure as well. We want to constantly be reviewing performance from a cost perspective, but also from a user's perspective. So there's a number of different things we can do on that. In terms of cost, scaling is really, really good for this. If you're a UK-based company, you don't want to be running your servers all the way through the night at full whack. You can just scale them back down or even turn them off. Like maybe the staging and testing environments, you can turn off entirely and then just spin them up when you need them. It's a really cost-saving tool, that is. And then probably the most important one there is security. I would suggest that most applications out there especially transactional websites, should be getting a regular pen test. You can do even automated scripting scripts to run pen tests on your site at a regular basis. It just highlights any sort of major flaws in your application. You can also do things like actually scan your code directly for any sort of automated to basically check if there's any glaring issues. And you can also scan Docker containers and or virtual machines, and it will go through all the settings to see if there's anything glaring obvious there. It seems simple, but subscribing to CMS patches is a real win. Just having that information for your team is really useful. And all the major cloud platforms are using policy as code, which is basically writing code for all your policies to make sure that people who have access to things only really need access to it. And something that's really overlooked is app monitoring. I think most teams really only concentrate on their infrastructure, but they completely forget about looking at what the actual application's doing at application level. So something we use is Sentry. There are plenty of other products out there, but what this does is it captures and aggregates our application logs. There's nothing worse than a customer ringing up and saying that they've got a problem with a website. You want to be ahead of the game and knowing what the problem is when they ring up. You can say, basically, this is the error, we're looking into it, or you can fix it before they even report it. The worst thing is that most customers probably won't even report the issue. They'll probably go to one of your competitors or just never come back to the website. So having a good dashboard of what's happening in the application is really good, and you can then basically, it's really good at debugging basically. So monitoring tools is probably the biggest list of monitoring tools out there. There's plenty of products out there. Either the cloud platforms are pretty good, but if you want an external view in there, there's a few there. I think Nagios is probably one of the best that's you can install on any server, and it has the most detail, but there's plenty of other tools as well.
Okay, cool. Gareth, thanks. Yeah, just wrapping up now, really the main three things we want you to take away today is to remember that obviously the goal of all of that is to increase collaboration and communication between the team members. So make a plan, share the plan, and over communicate it. Remember that you have to use the right tools for the job. Can automate a lot of things, and don't forget to measure everything from infrastructure and application. And then, yeah, the ultimate aim here is for everyone to be aligned on the goals, focus on the product, and increase the efficiency. But DevOps is really never done. So it's really mindset and a culture change that might be the biggest hurdle. But you just need to start your journey, start with one step of the process, little by little. If there's some manual steps, but as long as you take a small bit of everything we've discussed today, then you'll be well on your way for a good DevOps iteration.
Okay. Well, thank you very much, Sylvain, and for the rest of our speakers today. I hope everyone's really enjoyed the webinar. If you haven't done so already, please do go to our website where you can find our DevOps white paper and download it. If there's anything today that's triggered your attention or you'd like to know more, you can always pin us a message on Twitter with the hashtag DevOpsDuck. You can also reach us by our Twitter handle at cyberduck_UK, at LinkedIn with cyber-duck, or at email with hello@cyber-duck.co.uk. If you have any specific DevOps or technical questions that you would like to discuss with Gareth or Sylvain, we'd love to organize a meeting with them for a virtual coffee. And we can then discuss a little bit more in detail our approach and our methodology with DevOps. So I'm just going to see if there's any questions on YouTube. Please, anyone on YouTube or Zoom, drop any questions you have, and we will answer them for you now.
So the question was, do you have any tips to deal with multiple dev teams that have different work streams or tools? or do you ensure that any dev teams adhere to a standard DevOps approach? So Sylvain's answer was, when dealing with multiple development teams, our key tip is to find the common grounds with an architectural understanding of your products. You can plan which feature may impact the whole and prioritize the risks. You need to find one point where everything comes together. The earlier the better, i.e. sharing the same specification templates. But if it is not possible, they should at least merge into the same test suites before it gets deployed. And then Sylvain said, the second tip, have a release schedule. Fair warning, your stakeholders may not like this, but this could help your teams plan forward, have specific efforts ready in a queue. And last, from an architectural understanding, communicate, make that architecture visible. Everyone should know what impacts who. So yeah, that was one of the questions and answers that we had earlier.
So yeah, with advances like GPT-3, do you think DevOps will reach an automated nirvana? Thinking of automated testing mainly. Yeah, very interesting. Yeah, obviously the tools we can do more and more with the tools. And again, I think that's from my point of view. I don't know if others might have other point of view, but my point of view, that's GPT-3 is almost like, sounds like magic now. I'm a bit worried, like if we don't understand what the machine will do, how we can kind of ensure that there'll be exactly the quality that we want. Or ideally, we'll be able to feed, that would be perfect if we could feed the specification and then writing, if we were to write, and we can already do that. It's like it's some sort of language like Cucumber, stuff like that, where you can write almost the expectation in plain English and not turn that into a test suite. But with the more advanced AI, ML, and all the challenges on bias and not understanding what it does, then might become trickier. So one step at a time. We're still far away from that.
Thank you very much for that, Sylvain. So once again, thank you for joining us, and please do download our white paper.
Thank you. Bye-bye.
Thanks, everyone.